x squared plus 4x plus 3 over the square root of x. And our job, or our goal, is to find y prime, or another way to write that is dy dx. So find the derivative of this function. All right, so what were your thoughts?
You know, just for a lot of time we do all the stuff. So first of all, obviously, the square root of x, do that to
Okay, so this is great. As soon as I see, anytime I see a square root, a cube, root, a fourth root, any kind of root, I'm going to immediately rewrite that. So we'll rewrite this as y is equal to x squared plus 4x plus 3 over x to the 1 half. Okay.
Yeah, that's
Okay, so you got to this point, you said, I'm not really sure what to do now.
yeah.
Okay?
This just might be me, but it was easier for me to break them all out into separate. So x squared over x to the 1 half plus 4x. You know what I mean? Like break them all out.
Right, so divide the x to 1 half into each of these terms
Right.
over here.
Yeah.
Okay, so really at this point we have two choices. One option is that right now we have a fraction. And so that means that we can apply the quotient rule to this particular function and do low d high minus high d low, draw the line and square below. And that would absolutely positively work. The other option is, okay, I don't like the quotient rule. Or in this case, this did come out of 2.3, and technically the quotient rule isn't even introduced until 2.4. So we could use the quotient rule on this, but I think the textbook is actually intending to do what Nikki suggested, which is we can simplify this before we do any derivatives. So x squared over x to the 1 half is x to the 3 halves. Remember, we're going to subtract the powers to simplify. 4x over x to the 1 half is 4x to the 1 half. And our last term will be 3x to the negative 1 half. All right, so this is the option of simplify first and then take a derivative. Are there any questions on the simplify? Okay, so what I'm doing, so this first term, I'm distributing this x to the 1 half to each of the separate pieces up top. Is that 1, 2, 3? Okay. Now, I would not be able to do that if I had x to the 1 half plus something else in the bottom. Then things would be more complicated and I'd be more likely to use the quotient rule. But with only one term in the denominator, this is a really good idea. Okay, so yes?
Or we can divide like multiply divide by x of half.
Yes, so another way to write this would be x to the negative 1 half times x squared plus 4x plus 3, and then distribute that x to the negative 1 half through as well. Good. Okay, so now we've got our function. We now want to take our derivative. And so remember that we can use the notation y prime or dy dx. Either one works. And now that we've gotten rid of our division sign, we have 3 functions that are added together so we can take the derivative of each one separately. So our first derivative is 3 halves x to the 1 half, I've subtracted 1 from 3 halves, plus 4, well it's 4 times 1 half, which gives us 2, x to the negative 1 half. And our last one, I'm going to take this power and multiply it by 3, so that gives me a negative 3 halves. And I'm going to subtract 1 from negative 1 half, and so I end up with x to the negative 3 halves. And so here is my derivative. And this is a legitimate final answer. Yes, so if we, so this was our first option was to simplify. Option 2 is to use the quotient rule. And so we'll start with y is equal to x squared plus 4x plus 3 over, and I'm still going to write this as x to the 1 half, even before I make any choices about what rule I'm going to use. I want to get rid of those square roots. Okay, so the quotient rule says, when I think about this, I'm thinking low d high minus high d low, draw the line, and square below. Okay, so this is my quotient rule. So when I write down dy dx, my low is x to the 1/2. So low, I just copy that down, x to the 1/2, times the derivative of x squared plus 4x plus 3 minus pi x squared plus 4x plus 3 times the derivative of the bottom, derivative of x to the 1/2. Draw the line and square below. So x to the 1/2 squared. Now I'm not done taking the derivative, I've just really just set it up so far. So my next line will look like this. I've got x to the 1/2, and then I'm going to take the derivative of everything inside the parentheses, so I've got x to the 1/2 times 2x plus 4 plus 0. Minus, I'm going to copy down the next grouping in the parentheses, x squared plus 4x plus 3. Multiply that times the derivative of x to the 1/2, which is 1/2 x to the negative 1/2. All of that is over x to the 1/2 squared, which that simplifies down to just plain x. All of that is over x. And this is our derivative. And that looks very different than our derivative over here, but if we did some simplifying in both cases, we could get them to match up. All right, both are absolutely correct answers. Any questions about either one?